All right, in this presentation we're going to take a look at the different types of energy that exist and how they are either transferred from one object or one type of matter to another, or how it's transformed into one type of energy into another. So we need to start with a quick review, and we know that potential energy is energy that is stored. And so you can sort of think of it as energy that is sort of waiting to do something. So here we've got a picture of this guy with a ball at the top of a hill. And right now the energy that that ball has is potential because it's not actually doing anything right now. And we have to remember what energy is, and we'll talk about that in a little bit. And the second major category of energy is called kinetic energy. And that's the energy of motion, or the energy of what's happening or something that's going on right now. Now we've got this thing called the law of conservation of energy, and earlier in the year we talked about the law of conservation of matter, where you had a certain amount of matter before a chemical reaction and you had the same amount of matter after the reaction happened, but the matter was just sort of rearranged. And the law of conservation of energy is very similar to that. It states that energy is never created or destroyed. It's only transferred from one thing to another, or transformed from one type to another. So we've got some energy in this little blue dot here, and that energy can be transferred from one object to another. So you see we've got the same type of energy, it's the same color, it's still a green E. That energy is being transferred from the blue to the pink. And in this case, now the energy is being transformed. So it's changing into a different type of energy. You see now we have the green E's are moving somewhere else and they're turning into a different type of energy. And that's represented here by the different color E. So we can look at energy being transformed by using a simple model here, a pendulum, and I'm pretty sure most of you are familiar with it. You know, you've got a clock that has that little arm that swings at the bottom. So imagine that in your mind, and when the pendulum reaches the top of its swing, it actually stops for a moment. And since it's not moving, there's no kinetic energy. All the energy there is stored potential energy, and in this case it's gravitational potential energy. So as the arm of the pendulum begins to move, that potential energy is now being transformed into kinetic energy. So here we've got both potential and kinetic energy. And when it reaches the middle of its swing, or the bottom of the swing, there's no potential energy anymore, and it's all kinetic because that arm is moving. And in a moment we'll take a look at this in motion. Now as the arm begins to swing upwards, the kinetic energy is now being transformed back into gravitational potential energy. And again, when it reaches the top of its swing, it's all potential energy and there is no kinetic energy there. So if we look at this in motion, you can see that it stops right there and it stops right there. So each time it stops at either end of the swing, it's all potential energy. And when it reaches the middle right there, it's all kinetic energy. There is no gravitational potential energy there. Now in the middle of the swing, like right there or right there, there's a little bit of both. So what I want you to do in your graphic organizer, you've got a diagram that shows the pendulum in 5 different places. And I want you to label that diagram with either potential energy, kinetic energy, or both. So now that we are familiar with the 2 major categories of potential and kinetic energy, let's look at the sort of subcategories of energy. So it always helps to have something that will help you remember something. So when we think about the types of energy, we have to think about Mrs. G. Chen. Okay, and this is just a mnemonic device to help you remember. So the M in Mrs. stands for mechanical energy. The R is radiant, and that can also be called electromagnetic energy. The S is sound energy. The G is gravitational energy. The C represents chemical energy. The H is heat or thermal energy. And E stands for electrical energy. And last, the N is nuclear energy. So we'll take a look at each of these types of energy and sort of get an idea of whether or not it's potential or kinetic, or it could even be both, and maybe some examples of each as well. So before we start thinking about the different types, we need to remember what energy is. Energy is what makes matter do something, okay? It's what makes matter do work. And remember from that gizmo that work represented a force being exerted on something over a certain distance. So the first type we'll look at is called mechanical energy. And that's kinetic energy that something has because of its movement. So if we look at this example here, we've got the baseball bat on the ball. So there is energy in that bat as it swings and as it moves through the strike zone. And this is actually a good example of that mechanical energy being transferred from one thing to another. So the mechanical energy of the bat swinging is transferred to that ball, and it changes the way that ball moves. Okay, so it exerts a force on the ball, and it transfers the energy from the bat to the ball and makes that ball move a certain distance. Now, mechanical energy can technically even be thought of as potential energy because of an object's position. So when we think of an object that's raised high above a surface, like this guy that's going to jump 55 miles into the deep blue and set some world records here, he's got potential energy. Now the next type we'll look at is called radiant energy. And that can also, like I said earlier, be called electromagnetic energy. And that's kinetic energy from electromagnetic radiation. Now it's kind of hard to picture that as movement. How are things like sunlight and radiation, how are those kinetic energy? So when we think of light, light actually moves through space. I'm sure you've all heard of the speed of light. Well, the reason there's a certain speed to it is because that light is moving. And there are particles, really small particles, smaller than atoms, called photons. And that's the particle that sort of transmits light, the particle that light travels on. So if we think about this example here, we've got, I'm not sure if anybody knows what this is. This is actually what's called a solar sail. And what this is there's sort of that big sheet there of, looks like aluminum foil, and that's spread out. And what happens is light from the sun hits that sheet and actually acts as a sail, much like a sail on a boat on the ocean. When the wind comes and pushes that sail, it moves the boat along. And it's the same with this solar sail. Light hits that sail and pushes that spacecraft along. Now this is technology that's still sort of in its infancy, but it does hold a lot of promise for future space travel. Now sound energy is another type of kinetic energy. And the reason sound energy is kinetic energy is because that it occurs through vibrating waves through a substance. So, and I say a substance, but normally we think of sound traveling through air. Well, air is a substance. And what happens is something vibrates the air and sends waves through those particles. And the reason we hear things is because the movement of the air or the movement of those particles vibrate our eardrums, and then we're able to hear. So we've got energy being created by that speaker, and that's coming from another type of energy, and we'll talk about transforming energy in a moment. Now, gravitational energy is something that we're familiar with. We did some work with that gizmo where we put objects of different weights at different heights, and we were able to see how that changed the gravitational potential energy. So, like I said, it is potential energy that an object has because it's above a surface of something. So it's similar to that stored mechanical energy that we talked about earlier. So here we've got this giant rock perched on top of this little outcropping of rock, and it's got a lot of gravitational potential energy. And I want you to remember from the gizmo that gravitational potential energy is there because of the weight of an object and the height of the object. So if we've got a really, really heavy object that's high up off the ground, it's got a lot of gravitational potential energy. Now, if we have another object, like let's say a baseball, at the same height, it has less potential energy because it has less weight. Now, again, if we were to raise that baseball further up into the air, it would probably have to be really, really high to match the potential energy of that rock, but increasing the height of an object will increase its potential energy. Now, chemical energy is something that we've talked about, but never really got into the energy part of. We did a little bit when we talked about photosynthesis, though. Chemical energy is potential energy that is stored in the bonds of molecules. So when atoms are joined together in a molecule, there's energy that's holding them together. And if we think about this light stick, okay, you're like, well, what does that have to do with chemical energy? Well, inside that light stick, there's two liquids. There's one liquid, and then there's another liquid inside a capsule. And when you bend that to break that capsule, you start to mix those two liquids together. And what happens is a chemical reaction occurs, and that energy that is stored within the chemical bonds of those two liquids that are in there, as the chemical reaction occurs, energy is now released, and in this case, in the form of light. So that stored potential chemical energy is now converted into a different type of energy, or transformed. Heat energy, or thermal energy, is something that we talked about as well. And that is kinetic energy from the movement of particles of a substance. So remember what we talked about when we talked about phase change. When you increase the temperature of a substance, the particles begin to move faster and faster. Okay, so like I say, the more thermal energy something has, the higher the temperature of that object or that substance. Now, electrical energy is something we're all familiar with, and a lot of times when we think of energy, that's what we think about. We think about power plants generating electrical energy so that we can do things like turn on the lights or keep our food cold in the fridge. But electrical energy is kinetic energy, and it comes from the movement of electrons through substances. Okay, now that's kind of hard to understand, but if we think of a basic example here of an electrical wire, what an electrical wire is metal, generally it's copper, that's inside of a little plastic sheet. And what's happening in that copper is electrons are flowing through that wire. So you can see in the diagram below here, the atoms are sort of staying where they are, but the electrons are actually flowing through there, and because they're moving, they have energy. And that's how we get our electricity. That's how objects work. Now, the last type that we'll talk about is nuclear energy. Now, I know a lot of times people sort of get this queasy feeling when they hear nuclear energy, but we're not talking about nuclear power. We're talking about nuclear energy, which is where nuclear power comes from. However, when we just want to look at the source of energy. So nuclear energy comes from the nucleus of an atom. It's the potential energy that is stored within that nucleus of the atom. And it's there because the particles that are in a nucleus of an atom are trying to push themselves away from each other. It's kind of like trying to put two of the same ends of a magnet next to one another. They repel each other. The positively charged protons in the nucleus of an atom try to repel one another. They're trying to push away from each other. So it takes a force to hold them together. And that stored energy is nuclear energy. So here's a diagram or a picture that shows sort of how that energy is released when the nucleus of the atom is split. Some of that energy is released because it no longer has to hold those particles together. Okay, so now that we've talked about all the different types of energy that we're going to deal with, we need to think about our output page for this presentation. Now remember that when we talked about the law of conservation of energy, we said that energy is not created or destroyed, it's just transferred or transformed. So I want you to come up with a model. Okay, so for the output page, I'm going to give you these items, and I'm not going to physically give them to you. I'm going to sort of list them for you. Okay, you've got a battery, you've got wire, and you've got a light bulb. So what I want you to do is to create a diagram that shows how and where energy is either transferred or transformed. And you do need to include a written description here. So think about it. You may have to do a little research. What kind of energy is stored within a battery? Yeah, it's potential energy, but what kind of potential energy? Is it gravitational potential energy? I don't think so. Then that energy is transferred to the wire, okay? And it changes from one type of energy that's stored within the battery to another type of energy that is traveling through the wire. Then that energy is transferred to the light bulb, okay? And the light bulb lights up and it produces something. When a light bulb lights up, there is a certain type of energy released in the form of light. But there's also, those light bulbs don't stay cold, so there's also a release of another type of energy. So you're probably going to want to look online, do a little research as to how this works, and then draw a diagram of a setup where the battery and the wires and the light bulb are all connected, and the energy is transferred and or transformed throughout that system.